In this example, I want to construct a 99% confidence interval about the population mean weight in grams of pennies minted after 1982. Since we have a sample size less than 30, we need to check conditions for normality by inspecting the QQ plot and the box plot. In our class, we are going to ignore the need to check for the conditions of the confidence interval. I don't need you to check the QQ plot for normality, and I don't need you to check the box plot for outliers. We'll leave that out for this semester. What I'm concerned about is the confidence interval. So let's just focus on that. Here, if I want to do the work by hand, I notice there are 17 data values, so the sample size is 17. I have to find the sample mean, and I have to find the sample standard deviation if I want to do the work by hand. So instead, let's use technology to make our lives easier. This is a perfect example of when we should use technology. If you are going to do this problem on the computer, make sure you select the calculator that says confidence interval with data. Make sure you select the one that says with data since we're entering a set of data values. Make sure you enter the data separated by a comma, and I have already done that here. We want to calculate a 99% confidence interval, so enter 0.99 for a 99% level of confidence. Click calculate, and it gives us the sample mean, the standard deviation, but what I'm interested in is our confidence interval. I need the lower bound, and I need the upper bound. So these are the values we need for our confidence interval. I really want you to make a conclusion in a complete sentence, so let's phrase the lower limit and upper limit with a complete sentence. We are 99% confident and in this case we're talking about the mean weight of pennies minted after 1982. We are 99% confident the mean weight of pennies minted after 1982 is between, and we'll put our lower limit and our upper limit, between 2.45 and 2.48, don't forget the units, grams. So we are 99% confident the mean weight of pennies minted after 1982 is between 2.45 and 2.48 grams. In this example, a Gallup poll of 547 adult Americans conducted August 13 through 16, 2017 asked, how much total time in minutes do you spend commuting to and from work in a typical day? The survey results indicated the sample mean was 45.6 minutes with a sample standard deviation of 31.4 minutes. Let's construct a 90% confidence interval for the mean commute time. Is it possible that the mean commute time is less than 40 minutes? Is it likely? Before I begin the problem, I want to look at my variables. We know the sample mean is 45.6 minutes. We know the sample standard deviation is 31.4 minutes. I want to construct a level of confidence of 90%. And the sample size is 547 adults, given here. Now we can enter all of this information into the computer. If you're going to do this question on the computer, make sure you select the calculator that says confidence interval calculator for a mean with statistics. I need to enter the sample size. In our case, it's 547. The sample mean is 45.6. And we know the sample standard deviation is 31.4. Now I want to calculate a confidence interval for a level of confidence of 0.90 because we're doing a 90% confidence interval. Let's click calculate. Here's our lower limit and our upper limit. The lower limit and the upper limit. We have the lower limit is 43.39 and we have the upper limit is 47.81. Now we can make our conclusion. We are 90% confident that the mean commute time is between 43.39 and 47.81 minutes. We are 90% confident that the mean commute time is between 43.39 and 47.81 minutes. Is it possible for the mean commute time to be less than 40 minutes? Yes, it is possible to have a commute time that's less than 40 minutes, but it's unlikely since we have a 90% confidence interval from 43.39 to 47.81. 40 minutes is not within the interval, so it is extremely unlikely that there will be a commute time that's less than 40 minutes. Example. The 2006 General Social Survey asked 54 adults the following question. If ever married, how old were you when first married? This sample yielded the following results. The sample mean equals 22.2 and the standard deviation equals 4.9. Construct a 95% confidence interval for the mean age of adults when first married. Please pause the video and try this question on your own on the computer. There were 54 adults who were asked the question, so the sample size is 54. We have the sample mean, x bar, is equal to 22.2, and the standard deviation of the sample is 4.9. I'm looking for a confidence interval of 95%. So let's go on our statistics calculator and calculate our confidence interval. For this question, we'll use the confidence interval calculator with statistics again. Make sure you enter the sample size, and in our case, our sample size is 54. Our sample mean is given to be 22.2. Our standard deviation is 4.9. And we're looking for a 95% confidence interval, so change the confidence interval to 0.95. Click calculate. Just be aware, if you're doing the calculations by hand, your answers will be very similar, but they will not necessarily be exactly the same. When we're doing it by hand, we're using an approximation for the t statistic, so our values are going to differ. We have the lower limit is 20.86, and the upper limit is 23.54. Now we can write our conclusion. We are 95% confident the mean age when first married is between 20.86 and 23.54 years. We are 95% confident the mean age when first married is between 20.86 and 23.54 years.